Welcome back to 5.6. We're going to be talking about functions again. So let's talk about how do we know if something is a function? That's our first question. How do we know if a relation is a function? Good question. If we are looking at a table, it is a function if it has no repeating x values. So if all of the x's are different, then it is a function. If you're looking at a graph, it is a function if it passes the vertical line test. So let's look at these examples below and see if we can figure it out. So on example A and B, we're looking at tables. So we're looking for making sure none of the x's are repeating. So looking at the first example, A, looking at the x's, we have 1, 4, 3, we have 4 again. So since these x's repeated, it is not a function. Let's look at the next one. Looking at the x's again, 1, 2, 3, 4. Oh, it is a function. Now, with a graph, we are looking for our vertical line test. So let's try that. If you were to drag your pencil across your paper, or I'll kind of get a line. If I were to drag a vertical line across this graph, is there anywhere that line touches in more than one place? So right now it's touching my graph in one spot. Here it's touching in one spot, one spot, one spot, one spot. No matter where I put this line, it's only touching in one spot. So that means this one is a function. But if I go over here, look at when I drag my vertical line across this circle. It is touching at the top of the circle and the bottom of the circle. So 2 places. That is when your graph is not a function. So let's write ourselves a little note. So this one, the first one, is a function. It passed that vertical line test. It only touched my vertical line in one place, no matter where that line went. The second one touched my circle here and here, which was a no-go, so it was not a function. All right, now we're going to talk about inverse functions. So an inverse function is formed when the independent and dependent variables are reversed. What on earth does that mean? So let's graph this equation that they gave us in this first example. It says, let's graph the equation f of x, or y equals x squared. So take a second, head to your graphing calculator, and graph that function for me. Now that you've graphed it, it should look something like this. I had my table, I wrote it out for you, and it should end up looking like that lovely U. Now, to find the inverse of this function, what you're going to do is you're going to flip the x and the y. So if I have it, I'm going to say x equals y squared. I just replaced them with each other. So if I were to graph this, I needed to say y equals. So let's take the square root of that on both sides. So y is alone, and if I square root, I need a plus or minus. So I have square root of x with a plus or minus in front. Now on your calculator, if you go to graph this, you are not going to find a plus or minus button to write in your y equals. So in your y1, you're going to have to put positive square root of x, and in y2, you're going to have to put the negative square root of x. Graph that and see what it looks like. Okay, so when you did graph it, it should end up looking like this. And looking at your tables, you should also notice when we did this equation, look at our x's and our y's, And then we did this equation, and our x and our y's look like this. Our x's and our y's in each point also flipped. So that is what happens in an inverse function of one another. Now, let's make a little note to ourselves down at the bottom. A relation is a function if it passes the vertical line test. Oops. And its inverse is a function if the original equation passes the vertical line test. Okay, so let's practice finding the inverses of each of these equations. So they're giving us y equals 2x plus 1. So they want us to figure out what is the inverse of that equation. So the first thing you're going to do when you're finding an inverse is you're going to switch the x and y. Let's do that first. So I'm going to, instead now it's going to be x equals 2y plus 1. Now you can't just leave it like that. The second step you're going to do is you're going to solve for y. Get that y alone, make it look lovely. So if you did need to graph it, you could. So we're going to do that. I'm going to subtract 1. So x minus 1 equals 2y. And then I'm going to divide by 2. So y equals x minus 1 divided by 2. So there is my inverse function of that original equation. Let's do the same thing on the next one. I'm going to switch, this is y really, x and y. And I'm going to solve for y. So add 4. X plus 4 equals y cubed. And I'm going to get rid of that cubed by cube rooting both sides. So y equals the cube root of x plus 4. All right. Last one. Let's do the same thing. We're going to switch that x and that y. And then we're going to solve for y. So to solve for y, I'm going to, I got to get rid of that square root first. So I'm going to square both sides. So now that's an x squared equals x minus 5. And then I'm going to add 5 on both sides to finish off and get that y alone, leaving me with y equals x squared plus 5. And there's my final answer. Head on over to the 5.6 worksheet number 1 and do some practice.